Lesson 11.3 is on simplifying rational expressions. So in this lesson, you will learn to identify values excluded from the domain of a rational expression and simplify rational expressions. And the only vocabulary is rational expression. Okay, so we're going to continue by looking at excluded values. So the things that are outside of the domain, the things that make this not defined, right? So we cannot divide by 0. So we're still looking to see what makes our denominator 0, and that's going to be our excluded value. So what makes b plus 7 equal to 0? It's going to be negative 7. Okay, so my excluded value here is just x equals negative 7. Or, sorry, in this case, b. b can't be negative 7. Okay? What happens if we have something like this? I still want to know what values make the denominator 0. So here's where we have a fun review of factoring. So we want to know what makes this 0. So in order to do this, we want to factor. So remember, when we're factoring, we to negative 12 and add to negative 1. Okay, so if I'm thinking what adds to negative 12 and adds to negative 1, it's going to be negative 4 and 3. Okay, so I can write this as a minus 4 times a plus 3 equals 0. And that would give me this same equation up here. So if I have two things multiplied together equal to 0, I can use the zero product property and set each part equal to 0. So I'm going to get a is 4, where a is equal to negative 3. So my excluded values are 4 and negative 3. Okay? So same thing here. If I want to find the excluded values of this, I still want to know what makes the denominator equal to 0. So I'm going to do 2x plus 1 equals 0 and solve. So I'm going to get 2x equals negative 1. So x equals negative 1/2 is my excluded value. Right? So you guys find the excluded values for these. Okay, so example 2. Use rational expressions. The height of a cylinder with a volume V and a radius R is given by V equals pi r squared, with a height of a cylinder that has a volume of 770 inches and a diameter of 12 inches. Round to the nearest tenth. Okay, so we just want to be able to use this to find the height. Okay, so the height is equal to the volume divided by pi times the radius squared. And they tell us what the volume is right there. So I can put in 770 for my volume. And they tell us that the diameter is 12 inches. So if the diameter is 12, I know my radius is going to be 6, right? Because diameter is twice times the radius, or the radius is half the diameter. So I can put in 6 in for R. Okay, and I just want to evaluate this. So this is going to be 770 over 36 pi. And if you simplify that or put that in a calculator, you would get 6.808, and it says round to the nearest tenth. So rounding this to the nearest tenth is 1 decimal place. So it's just going to be 6.8 because that 0 keeps it at 8. Okay? So you guys do this one using that same equation. So I'll rewrite it for you. So the height of a cylinder is the volume over 2 times the radius squared. Pi times the radius squared, sorry. So using that formula, you guys do this one. Okay, so if we want to be able to simplify a rational expression, Let's let A, B, and C each be polynomials, where A and C are not equal to 0 because they're in the denominator and we can't have that. So, for example, here, let's say I have this. I have the same thing in top and bottom, and they can cancel out, and I'm just left with 3 over 4. So what I want to do is I want to factor the numerator and denominator of a rational expression as much as I can, so I can see if I could cancel anything. All right? So we want to know which expression is equivalent to this. So I'm just looking to see as much as I can simplify. So I'm going to start by looking at the numbers. So 32 over 4. 32 divided by 4 is 8. And then I look at the x's. So I have x to the 5th over x. So remember, I subtract the powers. So this is like x to the 1st. 5 minus 1 is 4. So I get x to the 4th. And then lastly, I want to look at the y's. So I have y squared over y to the 7th. Remember we said we can look at the bigger one and subtract the smaller one. So 7 minus 2 is 5. And I can put it where the bigger one was. So the bigger was in the bottom. So I'm going to put y to the 5th in the bottom. And that would be the same as letter B. Okay, you guys try simplifying this one. All right, last one, I think. Maybe not, we'll see. So I want to simplify numerator and denominator as much as I can. So I want to factor. So looking at the numerator, what's common to both terms? I have 4 goes evenly into both. So if I factor out of 4, I get x plus 4. Okay, and then I want to factor the bottom. So in this case, I want to multiply to 36 and add to 5. So for 36, what are the factors of 36? I have 1 and 36, 2 and 18, 3 and 12. This is 4 and 9, and 6 and 6. And I think that's all of them, and then just reverse them. So which of these is going to give us a difference of 5? And it's going to be 4 and 9. But I want one to be positive and one to be negative so that I get negative. And I want the bigger one to be negative so that I get to negative 5. So I'm going to have negative 9 and 4. So I'm going to write this as x minus 9 times x plus 4. Okay? And now when I did this, I ended up getting x plus 4 in both the top and bottom. So first, before I do this, I want to state excluded values, just like I did before. So my excluded values are x equals 9 and x equals negative 4, if I set each of these equal to 0. Okay? And then I can cancel. So simplifying this, I get 4 over x minus 9. And that's my simplified version of that problem. All right? So you guys do this one, state the excluded values, and simplify. Okay, for this one, we want to do the same thing. We want to factor this. So up top, this is a perfect square minus a perfect square. So if you guys remember, we can do the square root of each of them and do 1 plus and 1 minus. Okay, and on the bottom, they both have 8 goes evenly both into 8 and 40. So I'm going to pull out 8, and I'm left with x minus 5. Now, these don't necessarily cancel out because I have x minus 5 and 5 minus x. But I can say that x minus 5 is the same thing as negative x, or 5 minus x. Right? So like if I distributed that negative through, I would get negative 5 plus x, which is the same thing as a positive x minus 5. Okay? So if ever I want to switch the order, I can switch it by putting a negative out front. So I can say this is 5 plus x times 5 minus x over negative 8 5 minus x. Okay. 5 plus x, again, 5 minus x. Okay, and now I can cancel these. but I need to state my excluded values. So what value makes the denominator 0? X equals 5. So if I had 5 minus 5, that's 0. Or if I solve this, adding 5 to both sides. Okay, so now they cancel. So this is my excluded values. And then my simplified form is 5 plus x over negative 8. Or if I want to put the negative in front, I can do that. You just have to be careful here. Okay. So you guys do this one. Simplify and state the excluded values. Okay. So same thing, I want to simplify as much as I can. Or sorry, it says find the zeros. So zeros occur when the numerator is equal to 0. So for this one, I'm just looking at x squared plus 8x plus 7 and setting it equal to 0 and solving. So to do this, I want to factor. So that means I want to multiply to 7 and add to 8. So it's going to be x plus 7 and x plus 1. So once I have it factored, I set each part equal to 0 using the zero product property. And I get x equals negative 7 and x equals negative 1. And those are the zeros. Those are the values that make the whole function equal to 0. Okay, so you guys do this one really quick. Factor the numerator and set it equal to 0. And that is the end of 11.3.